Good afternoon, everybody. Welcome to the annual technical review workshop for the SONG San Dieguito Mitigation Project. My name is Kate Huckelbridge, and I'm the Deputy Director for the Coastal Commission. Before I turn it over to Mark Page and Steve Schroeder, the project scientist, I wanted to go over a few logistical items related to the Zoom platform and to describe a little bit about how we'll run this webinar. First, as I'm sure most of you are aware, this is our it's actually our second virtual webinar. We did our first one on Tuesday, and we have done our very best to prepare, but this platform is relatively new to us, and we ask for your patience as we address any complications or problems that may arise. Everyone attending the webinar has been muted and will remain muted during the presentations, and video has been disabled for all attendees. If you have a question for the team, there will be two ways to ask your question. First, you can type a question into the Q&A box that you can find at the bottom of your screen. When we come to the question and answer portion of the webinar, the team will walk through the questions as time allows and answer them verbally. Second, when we come to the question and answer portion of the webinar, you can use the raise hand function, also at the bottom of your Zoom screen, to indicate that you would like to ask a question. I will then unmute you one at a time and give you an opportunity to ask your question to the team. If we are not able to get to all the written questions, our team will try to put together brief written responses to be sent out after the webinar, but hopefully we'll be able to get to everything within the webinar itself. If you are not able to ask your question during a webinar, if you have technical difficulties or something else, please reach out to one of the team members via phone or email with your questions, and we will respond to you directly. All right, so with that, I'm going to go ahead and turn it over to Steve Schroeder to go over the agenda and start the workshop. Steve, you're on mute.
Thanks. Thanks, Kate. The agenda is up here, and I'm going to give a brief introduction, followed by the performance talk by Mark Page. And after Mark's talk, there will be a 15-minute period for questions and comments on the monitoring results. After that, I'm going to give a talk on salt marsh vegetation and biological standards, a status update, and adaptive management. And then after my talk, there will be a general discussion. Okay, and I'll move on to the introduction. So this is the annual review workshop for SONG's mitigation, wetland mitigation. Some background is important for understanding the purpose and rationale for the SONG's wetland mitigation project. The SONG's reactors were cooled by a single-pass seawater system. Units 2 and 3 have separate intake lines that are located in about 30 feet of water offshore of the power plant. When operational, the water was elevated 19 degrees Fahrenheit above ambient in the plant and then discharged through an extensive diffuser system, shown here, designed to dissipate the heat. Heated water from the power plant and turbulence was found to kill fish eggs, fish larvae, and small immature fish. These losses were projected to cause a substantial reduction in populations of the adult fish in the Southern California Bight. Construction of units 2 and 3 was found to be consistent with the Coastal Act only if these significant adverse impacts to fish were mitigated. The California Coastal Act requires mitigation to impacts to the marine environment. Enforcement of the Coastal Act resides with the California Coastal Commission. As mitigation for the impacts to larval and juvenile fish caused by SONGs, the Coastal Commission required Southern California Edison to first create or substantially restore a minimum of 150 acres of wetlands, excluding buffer zone and upland transition areas, and to provide funding for scientific oversight and monitoring of the restoration project that is independent of Southern California Edison. This slide lists some of the key elements of the SONG's wetland mitigation project. This mitigation is out-of-kind compensation for in-plant losses of larval and juvenile fish caused by the operation of SONG's units 2 and 3. Both physical and biological standards were established to evaluate the performance of the wetland restoration project. 1 year of mitigation credit is given for each year that the San Dieguito Wetlands Restoration Project meets the performance standards. Fulfillment of the SONG's wetland mitigation requirement will occur when the number of years of mitigation credit accrued by the San Dieguito Wetlands Restoration Project equals the total years of operation of SONG's units 2 and 3, including a decommissioning period to the extent that there were continuing discharges. This slide gives a timeline for SONG's units 2 and 3 operating conditions. So units 2 and 3 went online in 82 and 83 respectively, 1982 and 1983 respectively. In 2012, unit 2 and 3 operations were suspended because of a water leak internal in the freshwater system. In 2013, units 2 and 3 operations were permanently ceased and transfer of fuel to spent fuel rods occurred. The operating license was modified so that there was no operation of reactors, no fuel in the reactors, and it was a, quote, possession-only license. Okay, this map shows location of the San Dieguito Lagoon, shown in the green square here, the power plant, SONGS, and 2 of the reference wetlands, the Carpinteria Salt Marsh near Santa Barbara, Magoo Lagoon, and the Tijuana Estuary in South San Diego. Okay, this aerial photograph was taken in 2003 prior to construction of the San Dieguito Wetlands restoration. And you can see the San Dieguito River flows through it. You can see the I-5 freeway. Largely, the pre-restoration was ruderal or weedy uplands and old agricultural fields. And west of the freeway, a World War II dirigible airfield. And you can also see down here a portion of the what's termed the Fish and Game Basin that was established in 1978. This slide picture was taken in 2016 after completion of the grading. And you can see the creation of intertidal, subtidal habitats. You can see large subtidal basin to the west of the freeway. And you can see 4 nesting sites for California least terns, federally endangered bird species. These are not part of the project that we monitor. And you can also see here berms along bordering some of the intertidal areas. And these berms were to ensure that protect the wetland from a 100-year flood, to prevent it from filling in during 100-year flood. Okay, here's a timeline of the restoration. And the inset on the right, the upper right, shows the design. The green or salt marsh habitat, you can see the basin W1. So there's west of the freeway is a module called W23, east of the freeway W416 and W5, and then you can see the basin W1. Okay. Construction began in September of 2006, and as I pointed out, the excavation was and grading was organized by area and module. Most of the grading was completed in 2008, with additional tidal creeks excavated in W23 in November of 2010, and then W23 was regraded, and the elevation of a good portion of it was lowered in March of 2014. There was large-scale planting of salt marsh plants, including the cordgrass, Spartina, And this planting took place beginning in 2008, and then there was some Spartina planting in 2009, 2011. And then in 2016 through 2019, there have been a number of plantings of salt marsh plants. Inlet channel dredging was completed in September of 2011 with follow-up maintenance dredging that has occurred in November through December of 2015, 2017, and 2019. Performance monitoring began in 2012 following the initial September 2011 dredging. We are now in the 8th year of performance monitoring. Following construction, annual monitoring is required to evaluate the physical and biological performance standards provided in the SONGS permit. Monitoring tracks ecosystem development and identifies adaptive management opportunities pertaining to both the physical and biological functioning of the wetland. And as I said before, independent monitoring is conducted by scientists from UCSB, Mark Page and myself, with advice from our science advisory panel, Pete Raimondi, Rich Ambrose, and Russ Schmidt. The wetland restoration is providing habitat for invertebrates, for fish, there's a sand bass, birds, and plants. San Dieguito Wetland provides nursery habitat and supports endangered, rare, and unusual species. This includes provision of nursery habitat for juvenile California halibut and habitat for the endangered ridgeway or clapper rail. It also provides habitat for the state listed Belding savanna sparrow, and we have a number of rare visitors, and here's an example of a Eurasian widgeon. Although the wetland is providing resource value, it has not yet met the performance criteria required for successful mitigation. And this is going to be discussed in the next presentation by Mark Page that reviews the results from performance monitoring in 2019. Mark.
Mark, you're muted.
Okay.
There you go.
So we're learning here. There we go. As I mentioned, this presentation focuses on the 8th year of performance monitoring of the San Dieguito Wetlands Restoration Project. And our evaluation of the progress of the restoration project towards meeting the performance standards that are required for successful mitigation. And I would like to begin by thanking our field crew who collects the data that will be presented today, as well as members of the SAP, our science advisory panel, as Steve mentioned, Rich Ambrose, Russ Schmidt, and Pete Raimondi, for reviewing and providing comments on these presentations. So there are two types of standards that are used to assess the performance of the restoration project. The first type are termed absolute standards, and these are standards that are measured only in San Dieguito wetlands. For example, the area of wetland habitats shall not vary by more than 10% for the acreages provided in the final restoration plan. The second type of standards are termed relative standards, and these are measured against natural wetlands that serve as reference sites. For example, the densities and numbers of species of birds in San Dieguito wetlands shall be similar to that of natural wetlands in the region. Let's begin by talking about the absolute standards first. And the requirement for the absolute standards is that the San Dieguito Wetlands Restoration Project must meet each absolute performance standard for that year to count towards mitigation credit. The evaluation of each absolute standard is based on the value for the current year. The absolute performance standards for the San Dieguito Wetlands Restoration Project pertain to tidal prism, habitat areas, topography, plant reproduction, and exotic species. So the tidal prism is the volume of water exchanged in an estuary between the high and low tide levels. And it's an important metric of tidal flushing, inundation of marsh habitat, and inlet stability. And the standard for tidal prism specifies that the tidal prism shall be maintained. The habitat area standard specifies that the area, as I mentioned, of the different wetland habitats shall not vary by more than 10% from the planned values in the final restoration plan. The absolute standard for topography requires that the wetland not undergo major topographic degradation, for example, excessive erosion or sedimentation. The plant reproductive success or plant reproduction standard requires that certain plant species have demonstrated reproduction, that is seed set, at least once in 3 years. And finally, the standard that pertains to exotic species requires that the important functions of the wetland shall not be impaired by exotic species. And exotic species can have negative impacts on wetland functioning, for example, by altering food webs or the physical structure of habitats. Well, this slide summarizes whether a particular absolute standard was met during each of the last 8 years. So in a format that we follow through the rest of this talk, a green dot indicates that a standard was met, and a red dot indicates that a standard was not met. And you can see from this figure that San Dieguito Wetlands has met all of the absolute standards the past 8 years, except for the habitat area standard. And so we'll now take a closer look at the results for the habitat area standard. Well, taking a look at this standard in detail, again, the area of different habitats are required not to vary by more than 10% from the areas as acres indicated in the final restoration plan. And this performance standard is designed to preserve the mix of habitats provided in the final restoration plan and guard against large-scale conversions of one type of habitat to another. For example, of vegetated marsh to mudflat or vice versa. So the panel on the left shows the planned locations of the salt marsh indicated by the green, mudflat is brown, and subtidal is blue habitats that are provided in the final restoration plan, as well as the planned acreages for the different habitats shown below it. Well, taking a look at the criteria that are used to assess habitat areas, habitat is assessed as salt marsh if it's intertidal and less than or equal to 4.5 NGVD, and it has greater than 30% cover vegetation, which is evaluated using aerial imagery in 10 by 10 meter grids that are spread that cover the entire wetland. There is another standard that pertains specifically to vegetation cover, and this is evaluated under the relative standards. Habitat is assessed as mudflat if, again, it's intertidal, but lower, less than 3.5 NGVD, and has a low cover, virtually no vegetation at less than 5% cover vegetation, and mudflats are typically defined as intertidal and unvegetated. And finally, habitat is assessed as subtidal if it's continually submerged. So on the right here, we just have some examples of mudflat habitat located lower intertidally, sparsely vegetated. You can see no vegetation there. This, on the right here, we have elevation that's too high for mudflat. It doesn't have vegetation, but it's too high to be categorized as mudflat. And then, of course, we have subtidal habitat. So in this slide, we have the habitat or the acreages of the different habitats as the planned acreages as specified in the final restoration plan. So on the left y-axis, we have acres, and along the x-axis, the bottom axis, we have the different habitats. The open bars indicate the planned acreages, And the red horizontal lines indicate values plus or minus the planned acreages. Also shown is a category that we term other. So if we take a look at the photos on the right, we have salt marsh habitat that's assessed as salt marsh. It has a nice cover vegetation, 30% at least. In contrast, if you look at the photo below that, you can see that it's very sparsely vegetated. And as a result of that, it's too high. It's also too high in our tidally be assessed as salt marsh, too high to be assessed as mudflat. And as a consequence of that, we throw it in this other category, which is not a planned habitat. So taking a look at the results, the monitoring results for 2019, the solid black bars indicate the acreage is determined in our 2019 survey. And so while you can see the acreages of subtidal habitat are within planned values, that is slightly less, maybe a little over 3%, the acreages of mudflat fall slightly below planned acreages at minus 10.7%, and salt marsh habitat falls about 23% short of the planned acres. If we take a look at the table on the right, we can see that, in fact, salt marsh, the acreages for salt marsh in 2019 were 71.1 acres, which is about 12 acres short or below the lower 10% limit for the designed acreages. As a result of that, the standard for habitat areas is not currently met. Well, this slide shows a trend over time in the acres of the different habitat categories, as well as the other category, that is not a planned habitat, on the lower right. Okay, here we have, if we take a look at the salt marsh panel up in the upper left, we have a solid black line indicating the planned acres. The dashed red lines indicate plus or minus those values. And we can see from this that there's been a general increase, which is very promising, in the acres of salt marsh habitat, particularly over the past year from 2018 to 2019, perhaps associated with increased rainfall that we had during that period. But we're now about 12 acres short. Taking a look at the mudflat habitat, this is a little bit concerning because you can see a slow decline in the area of mudflat habitat. And again, it's fallen slightly below the 10%, the lower 10% value. And this is something that we're going to be keeping an eye on as we move forward. But it could likely be in part due to the encroachment of Spartina into low marsh, which is present in the low marsh, into areas that are actually planned mudflat. What is encouraging here, if we take a look at the other category in the lower right, we can see that there's been a decrease in the amount of other habitat, that is this unplanned habitat. It's not even a habitat by the fauna restoration plan, this category, which reflects the filling in of vegetation, particularly at lower elevations. So moving on to the relative performance standards. The second type of performance standards are these relative standards, and they're evaluated against natural wetlands in the region that are used as reference sites. And the valuation of each relative standard in a given year is based on the average calculated, calculated from data collected at San Dieguito Wetlands and the reference wetlands for that year and for the previous 3 years. In other words, a running average. Okay, so what counts as similar in the context of assessing the performance of the San Dieguito Wetlands Restoration Project? Well, the 4-year running average for a relative performance standard at San Dieguito Wetlands must be equal to or better than the value for the lowest performing reference wetland for that standard. And the rationale behind this is that to be successful, the San Dieguito Wetlands Restoration Project must provide resource values that are similar to those of natural wetlands in the region. And a running average is used rather than the value for the current year because it better accounts for natural fluctuations over time. So the criteria for the inclusion of a wetland as a reference site is provided in the Solon's permit. The SONGS permit asks or requires that the reference wetlands be relatively undisturbed, tidal, and located in the Southern California Bight. And we evaluated 46 wetlands as possible reference sites, and Carpinteria Salt Marsh, Magoo Lagoon, and Tijuana Estuary were selected as best meeting the criteria provided in the SONGS permit. Well, shown here in this slide are the 15 relative performance standards that are used to evaluate the success of the San Dieguito Wetlands Restoration Project. The first standard pertains to water quality, which is a physical factor. Standards 2 through 11 pertain to biological communities. That is the communities of birds, fish, and invertebrates. Standards 12 through 14 pertain to the cover of vegetation, salt marsh vegetation, the cover of algae, macroalgae, and Spartina canopy architecture. The last standard pertains to food chain support as provided by the wetland to feeding of birds. So we'll now run through each of these standards, take a look at whether they've been met or not met. So again, similar to the figures for the absolute standards, we have green representing the particular standard was met, and red indicating that a particular standard was not met. And we also have a few cases where there's no data collected for various reasons. So this slide summarizes the results for water quality. Water quality is the variable that we use to evaluate dissolved oxygen concentration is the variable that we use to evaluate the water quality standard. And we do this because of its demonstrated importance in wetland health. So we assess dissolved oxygen concentration by comparing the mean consecutive hours of hypoxia. That is the case where the dissolved oxygen concentrations are low, less than 3 milligrams per liter, between San Dieguito wetlands and the reference wetlands. If the mean number of consecutive hours of continuous hypoxia is significantly higher in San Dieguito, you're spending more time under conditions of low oxygen than the reference wetlands for the highest value, then San Dieguito wetlands fails to meet the standard. In fact, water quality and dissolved oxygen specifically has been very good in San Dieguito wetlands, and they have met this standard for the past 8 years. And the standard is currently met, 2019. So we're now moving on to the performance standards for biological communities, which includes the standards for birds, fish, and invertebrates. And these are relative standards that pertain both to the densities and species richness of these groups. The performance standards for biological communities requires that the total densities and numbers of species of these groups, that is birds, fish, and macroinvertebrates, shall be similar to the densities and numbers of species in similar habitats in the reference wetlands. And note here that we actually evaluate the standards for fish density and fish species richness and invertebrate density and invertebrate species richness in both tidal creek and main channel habitats indicated by the MC and TC. Well, you can see by the number of red dots in 2019 that there were 6 biological standards that were not met in 2019, and 3 of which were met in 2018. So standards that were not met include bird density, include fish species richness in main channels, include fish species richness in tidal creeks, invertebrate density in main channels, invertebrate density in tidal creeks, and finally, invertebrate species richness in tidal creeks. So we'll now take a look at the results for the standards that were not met in more detail. Well, this slide shows the annual average on the left and running average on the right, which is, this is what we use, the running average is what we use to evaluate the standard for the density of birds as number of birds per acre. And notice the difference in y-axis scale between these two figures. The y-axis scale is different on the right-hand figure, the running average figure, so that you can better see differences between the wetlands. Taking a look at the running average, we see that there has been a general decline. So in this case, the green triangles represent San Dieguito Wetlands. The yellow diamonds represent Tijuana. The blue squares represent Carbon-Free Salt Marsh. And the red dots indicate Magoo. And so that you can see that Magoo has had consistently high densities of birds. You can also see that San Dieguito Wetlands has had a general decline in the densities of birds in terms of the running averages over the past few years. This standard was actually met in 2018, but was not met in 2019. So unfortunately, this standard is not currently met. Another relative standard that was met in 2018, but not met in 2019, is fish species richness in main channel habitat. So if we take a look at the annual values, we notice that fish species richness declined from 2016 to 2017 and has remained low and below the reference sites since that period. If we take a look at the running averages on the right, we notice that the running average for 2019 is not similar to the worst performing reference wetland, and consequently, the standard is not currently met. Taking a look at the species richness of fish in tidal creeks, there's been, and looking at the running average here on the right, again, the green triangles are San Dieguito. The running averages for the reference wetlands, if you look at, say, Carpinteria and Tijuana, have been relatively constant over the past few years. But the running average for San Dieguito Wetlands has decreased and has now gotten to the point where it's below the lowest performing reference wetland. So as a result, the standard was not met in 2019. Moving on to the invertebrate densities in main channel habitat. This slide shows again the annual averages on the left and the running averages on the right. And the running averages again are used to evaluate the standard of densities of macroinvertebrates as number of individuals per square centimeter. If we take a look just at the running averages on the right, we can see that the running averages for San Dieguito have been consistently below the lowest performing reference site, which is Tijuana Estuary. Again, this year, the running average for San Dieguito has remained below the lowest performing reference site, and as a result, the standard is not met. I think what's interesting about this figure is that, except for this decline that occurred in Magoo, the wetlands more or less track each other. It's just that San Dieguito is below the lowest performing reference wetland. Moving on to invertebrate densities in Tidal Creek. Looking at the annual average on the left, we see that the value for San Dieguito Wetlands declined from 2016 to 2017 and has remained low the past since that point. Okay. Take a look at the running averages for invertebrate densities in Tidal Creek habitat. We see that for San Dieguito Wetlands has remained relatively flat, little changed from 2015. In contrast, it looks like the densities actually were tracking upward at the three reference sites, although the increase at Tijuana Estuary is not as dramatic as it was at Carpinteria Salt Marsh and at Magoo Lagoon. So because San Dieguito is below the lowest performing reference site in 2018 in terms of densities of macroinvertebrates and tidal creeks, the standard is currently not met. Moving on to invertebrate species richness in Tidal Creek, that is the numbers of invertebrate species or taxa. This slide, this standard actually was met again, was one of those that was met in 2018. But if we take a look at the annual average on the left, and it's very apparent in the running average on the right, there's been a general decline in invertebrate species richness in the Tidal Creek habitat. Again, this standard was met in 2018, but the standard is not met in 2019. and it's tracking in a different direction than the reference wetlands, which seem to slightly increase over this period. Okay, because San Dieguito Wetlands is not similar to Tijuana Estuary, the lowest performing reference wetland, the standard is not currently met. The next three standards, relative standards, pertain to the percent cover vegetation, macroalgae, and to Spartina canopy architecture. So as I mentioned earlier, vegetation cover and the salt marsh habitat is determined from aerial imagery that is used to evaluate the habitat areas. And you can see from this table that San Dieguito Wetlands has yet to meet the relative standard for vegetation cover. The performance standard for algal cover is designed to monitor the development of unusually thick mats of green filamentous macroalgae. And thick mats of algae have the potential to interfere with wetland structure and function by smothering benthic invertebrates, interfering with bird feeding, and then decomposing mats of algae can actually adversely affect water quality. This standard for algal cover in San Dieguito Wetlands is met if the cover in San Dieguito is not significantly higher than the reference wetland with the highest cover. And San Dieguito Wetlands has met this standard in all 8 years of monitoring. Finally, taking a look at Spartina canopy architecture, the standard for Spartina canopy architecture requires that the proportion of stems over 3 feet tall in the stands of Spartina shall not be lower in San Dieguito Wetlands than in the reference wetland with the lowest proportion. So the rationale behind this standard and the use of the 3 foot length of stems criteria is that it was determined that stems 3 feet or taller are required nesting habitat for the endangered ridgeways rail. In practice, our comparison has only been made between San Dieguito Wetlands and Tijuana Estuary because Tijuana is the only reference site with sufficient Spartina stands to evaluate the standard. San Dieguito has very robust stands of Spartina, as you'll see in Steve's talk, which follows this one. And this standard has been met from 2013 to the present. Well, let's take a look at for the one relative standard of those three that has not been met, and that is the percent cover of vegetation, which is shown on this slide. So again, the annual average is on the left, the running average is on the right. And San Dieguito Wetlands was colonized by vegetation fairly early on, and vegetation increased in cover, although slowly, but unfortunately has not yet reached the point where the running average is similar to the cover of the reference wetlands. Although we believe that there's an encouraging trend, and so that's very promising. And Steve will speak more about ongoing activities to increase the cover of vegetation in San Dieguito Wetlands in the next talk. Standard is currently not met, however, for cover of vegetation. Well, the final relative performance standard pertains to food chain support as measured by the density of feeding birds. In this standard, you can see, taking a look at the dots here, the green and red dots along the bottom of the figure, has been met 5 of the previous 7 years, but has not been met the last 2 years. It was not met, so let's take a look at the figures, the data for that. So food chain support has consistently been highest in Magoo. If we take a look at the running average on the right, we see that it's been the data from Magoo, the food chain support values in Magoo, as the density of feeding birds per acre has been much higher than the other wetlands. As I mentioned, San Dieguito was the last couple of years. It's not been met. This standard has not been met in San Dieguito Wetlands. So unfortunately, this standard is not met for 2019. It's fallen slightly below the value of the lowest performing reference wetland, which is Cordgrass salt marsh. So unfortunately, it's not met for 2019. Well, let's review the requirements for the relative standards. The San Dieguito Wetlands restoration must meet at least the same proportion of relative standards. as the lowest performing reference wetland in a given year for that year to count towards mitigation credit. San Dieguito wetlands and the reference wetlands are evaluated as to whether or not they meet each relative standard compared to one another, and the proportion of relative standards met by each standard is computed and compared. The rationale behind this method of evaluation is that requiring San Dieguito wetlands to meet at least the same proportion of relative standards as the lowest performing reference wetland achieves the desired mitigation goal of being similar to natural wetlands without requiring the restoration to outperform the reference wetlands. In other words, being a super wetland. Well, this table provides a summary assessment of the relative performance standards for 2019 as evaluated using the running averages. Again, the green dots represent that a standard has been met. The red dots indicate that a standard has not been met. The gray values are indicate that values are not available for that wetland. Well, comparing the running averages for 2019, we can see that that year was a very good year for the reference wetlands. That is, they met the same proportion of relative standards. San Dieguito wetlands only met 7 of 15 standards, or about 47%. Consequently, San Dieguito wetlands did not meet the relative standards for 2019. Well, taking a look at project compliance, in order to receive mitigation credit for a given year, the wetland restoration project must meet all of the absolute standards and as many of the relative standards as the worst performing reference wetland. So far, San Dieguito wetlands has yet to meet the habitat area standard due to slow vegetation development. The project has also failed to meet the relative standard requirement due to slow rate of vegetation development that affects the percent cover, low densities of invertebrates in tidal creek and main channel, and low density and species richness, or low species richness of fish. As a result, the project has not yet satisfied the performance criteria in the SONGS permit and has not yet received mitigation credit. So in the next talk, Steve will discuss in more detail the status of the vegetation and salt marsh habitat, the ongoing planting program, and status and plans to examine the underperformance of biological communities. Before we get to Steve's talk, though, we can take some comments and questions. We've reserved about 15 minutes or so, and then we'll have a general discussion at the end after you've heard Steve's talk. So.
Thank you, Mark, and thank you, Steve. So now we will have an opportunity for folks to ask questions. And again, just as a reminder, there's 2 ways to do this. You can type a question into the Q&A it's sort of a little window that pops up, and we'll try to answer those as they come in. Another option is if you have a question you'd like to ask, you can use the raise your hand function, and I will unmute you, and you can ask your question to the group. So now's your opportunity if you have a question you want to ask. So I'll give it just a minute. I don't see any right at the moment, but I'll give it a minute just to make sure everybody can find the right buttons in case they have a question.
Sure. And then some questions might be answered by Steve in his talk as well, concerning what are the plans in the coming year to deal with some of these underperforming standards.
Mm-hmm. Okay, so I am not seeing any questions. So let's just go ahead and move straight into Steve's talk on the marsh vegetation and biological standards.
Okay, let me get that up. Okay. Okay, wait a minute.
All right, just give us one moment. Bear with us while we get our shared screen up. 1 second.
Okay. Let me see. Vegetation. Okay. Almost there. Wait a minute. Hold it. Sorry.
Mhm.
Okay. There we go.
Great.
Okay. Okay.
Steve, you want to stick it in presentation mode? There we go.
It is in
Got it.
presentation. Okay.
Got it.
Okay. Okay. Thanks, Mark. Okay. As Mark said, this talk is going to present a status update on salt marsh vegetation and biological standards. First, I'm going to discuss salt marsh vegetation, and this is important in the presentation because the habitat area standard, including the areas of vegetated salt marsh, is an absolute one that must be met every year. And it has not been met since the beginning of our performance monitoring and has been the focus of adaptive management activities over the past several years. In addition to this, we will be focusing on the relative standards that have not been met in the coming year. And for today's presentation, we will discuss two of these, the densities of birds and invertebrates. But the salt marsh vegetation hasn't, as I said, the habitat area standard has not been met, nor has the relative standard of vegetation cover been met. The biological standards that have not been met, as Mark pointed out, are the densities of birds and invertebrates, species richness of fish, and bird feeding, or the food chain support standard. Just to go back over what Mark discussed, the absolute standards for habitat areas is that the different habitats shall not vary by more than 10% from the areas indicated in the final restoration plan. And the relative standard for vegetation is that the proportion of total vegetation cover in the marsh shall be similar to those proportions found at the reference sites. To be assessed as salt marsh habitat, as Mark pointed out, the cover of vegetation must be at least 30%. And this 30% is evaluated within 10 meter by 10 meter grids covering the entire wetland, as discussed by Mark in Mark's performance talk. The second standard pertains to the cover of vegetation, is the second standard that pertains to cover of vegetation is the vegetation standard. This is a relative standard and requires, again, that the proportion of total vegetation in the marsh shall be similar to those proportions found in the reference sites. This slide, again, goes over something that Mark discussed, and it shows the graph on the left shows the acreages on the y-axis of salt marsh vegetation habitat over time on the x-axis. The red line is the required acreage in the design, and the dashed lines indicate plus and minus 10%. As Mark pointed out, currently in 2019, the acreage of salt marsh habitat is about 12 acres short of the 83.3 acres, which is a lower 10% of the design acreage. And again, this inset on the right shows an example of the sparsely vegetated habitat that is neither mudflat nor salt marsh and is put into the other category. One of the things that's been very positive has been the distribution of cordgrass or Spartina in the San Dieguito Wetlands. And this is a summary of the coverage, an area of Spartina in both east and west of the freeway. This photo, or this aerial photo, shows the area of cordgrass, which is in yellow, both east and west of the freeway, and around the tidal basin W1. And it's important to note, you can see here that on W23 west of the freeway, cordgrass has actually colonized some of the tidal creeks in W23, as well as actually in W416. After a slow start, following extensive planting in 2011, the area of cordgrass has increased steadily over time, and it took a big jump between 2018 and 2019. It's currently at about 13 acres. This increase was 6 acres between 2018 and 2019. The relative standard for vegetation cover requires that San Dieguito wetland coverage of vegetation shall be similar to the 3 reference wetlands: Magoo Lagoon, Carpinteria Salt Marsh, and Tijuana Estuary, and these are typical shots of these wetlands. The average coverage in the wetlands is around 85%. This slide shows a timeline in changes in acreage of those cover classes that count as salt marsh vegetation. And for the purposes of this talk, we put them into 3 categories: 30 to 60% cover, 60 to 80% cover, and the green triangle is the highest cover class, equal to 85% or greater. And similar to, this coverage is similar to the reference wetlands, as I indicated. And you can see that there has been a big increase in this highest cover class between 2018 and 2019, which is encouraging. Okay, this is a composite from aerial photographs, and we can use the aerial monitoring to help identify areas in the wetland where the vegetation is underperforming. And as I said previously, these pixels are actually 10 meter by 10 meter squares that cover the entire wetland, and the cover in these pixels is evaluated to determine the cover of salt marsh vegetation. Brown shows planned mudflat in this picture, and then there are several classes: red, which is 0 to 10% cover; orange, which is 10 to 20% cover; and yellow actually between 20 and 30% cover. And these are all cover classes that do not qualify or are not classified as salt marsh vegetation. And then there are 3 cover classes that are 30% cover or greater, going from light green to dark green, and the darkest green is the 85 to 100% cover. And then you can also see here a subtidal, which is in blue. Okay, this is and I didn't tell you this, but okay, I'll go over here. This is the same image for the modules W23 and W1 west of the freeway. And again, the same cover classes shown here. Modules W1, the large basin, has a fringing salt marsh habitat and mudflat. And we can see that about 14 acres of the 20 acres of W23 had achieved at least 30% cover in 2019, and that 5 to 6 acres of sparse vegetation remain, particularly at the higher elevations and at the eastern end. And only 2 of the 20 acres have achieved at least 85% cover of salt marsh vegetation in W23. To facilitate plant development, SCE has undertaken a planting program. In 2017, Southern California Edison tilled some areas and installed irrigation lines in preparation for planting in 3 areas, which are outlined with the black line and indicated by planting areas. And in March of 2019, they planted about 39,000 plants. And the inset on the right shows one of these areas is actually the planting area I'm indicating here with my cursor. And you can see the evidence of some tilling and the irrigation lines. And these plantings were done in 2 sizes of containers. The circle on the right indicates the gallon pots, and these are containers that are about 6 inches in diameter and 7 feet deep. And the container that is outlined in the dashed yellow circle are so-called rose pots, and these are about 3 1/4 inch diameter and 2 1/4 inch deep, so they're much smaller. In 2019, we conducted experiments to inform the SCE planting program. Embedded in the larger area that I showed in the previous slide was an experiment that is designed to test the effects of container size, whether we use rose pots or gallons, and clumping, whether we planted plants in singlets, shown here on the inset on the right, or in clusters of 3. The rationale for this experiment was that soil salinity decreases with depth in the soil, and plants in larger pots may have deeper roots that extend into this lower salinity soil at depth. In addition, the larger gallon pots have more planting soil, which may facilitate plant growth and survival. The rationale for the clustering was that closer spacing of planted plants may improve microhabitat conditions, for example, salinity and moisture, favorable to plant growth. And we've noticed this in sampling that we've done over time, in which in the middle of clumps, you tend to get lower salinity and higher moisture content. Okay, this slide is an overview of the 2019 experimental plantings. And the actual experiments were conducted here, shown in the 3 or 4 areas that are outlined in black, indicated by either the white lines or the blue lines. Okay, this slide just summarizes the results of that 2019 experiments. And what we found was that plants in gallon containers perform much better than plants in the smaller rose pots. In addition, clustering conferred no obvious benefit on plant performance. The results from this experiment were used to inform the planting program in 2020. SCE's planting program has continued in 2020 with additional plantings of about 21,000 plants. 73% of these plants were Arthrocnumum or Parrish's glasswort, and there were 5 additional species planted as well. And again, you can see the areas that are irrigated in black, and the numbers indicate the number of plants that were planted in each of these areas. Based on the 2019 experiment, all of these plants were plants grown in the nursery in gallon containers, and they were planted as singles with the spacing between 1.5 to 2 feet. Okay. Two experiments were embedded in the 2020 planting program, which I will now describe. The goal of the first experiment was to test the effects of irrigation, soil decompaction, and soil amendments on the growth and survival of potted plants and of seeds. And these were done at those higher elevation areas that in the previous slide that were all red, that showed that there was little or no vegetation cover. The second experiment was designed to test the effects of planting versus seeding on filling in gaps in plant cover at lower elevations that were areas that were sparsely vegetated but did have vegetation of around 10%. In this experiment, there were no soil treatments or irrigation. So these insets on the bottom show some details of that first experiment. The decompacting was done by a large bulldozer that pulled 1.5 foot to 2 foot tines through the soil. The middle inset shows the addition of amendment, and the darker amendment area in this slide, the darker areas in this slide are it's a commercial soil amendment, and the light white is gypsum. And so these gypsum and the commercial soil amendment were applied, and then they were actually decompacted to mix the amendment into the soil. And on the right, you see the inset that shows the location of the quadrats where either Parrish's glasswort plants were planted or there was seeding. And then we also had a control where there was no seeding or planting. And then there was a treatment that had just seeding. And the small inset up here shows the distribution of the glasswort that are spaced uniformly 2 feet apart in each one of these quadrats. And you can see here a little marker that facilitates identification of the cover in the various treatments that we assess through high resolution drone imagery. This is a plan view of the experiments in east of the freeway in W23. The star shows the general location, and this the bottom picture shows a schematic of experiment 1. The experiment consists of 3 blocks, and in each block there's a sub-block, one of which is irrigated and one of which is not irrigated. And then in each of these sub-blocks we have the various soil treatments that I discussed. And again, this is at high elevation between 4.2 and above 3.5 NGVD, but pretty high in the intertidal. And then the gap experiment, experiment 2 that I described previously, is outlined in red. And here we had actually 3 blocks, but no irrigation, no soil amendment. And we planted 3 different species of plants, including the glasswort. And we had a seeding treatment and a control where no planting or seeding was done. Okay, to summarize the vegetation and indicate future directions, underperformance of vegetation has led to a shortfall in salt marsh habitat and vegetation cover. It appears that favorable conditions, most likely rainfall, has led to a large increase in both vegetation acreage and cover. SCE is now implementing a planting and irrigation program in portions of the wetland to facilitate vegetation development. And in 2019 and 2020, approximately 60,000 plants have been planted, the majority of which are the parish's glasswort. An experiment was completed in 2019, and it revealed that plants perform better in gallon versus rose pots with no effect of plant clustering. Experiments started in 2020, actually started at the end of February, are currently underway to evaluate the effect of irrigation, decompaction, soil amendments, planting, and seeding on the development of plant cover. We, the CCC contract scientists, are monitoring the experiment and the overall planting program to evaluate whether they achieve the desired goal of increasing vegetation cover in a timely manner. Okay, now I want to turn from the vegetation to performance standards pertaining to biological communities. These are relative standards. They require that the measured performance variable be similar in the San Dieguito Wetlands to the reference wetlands. And examples of this are the total densities and numbers of species of fish, macroinvertebrates, and birds that shall be similar to densities and number of species in similar habitats in the reference wetlands. To review from Mark's presentation, the restored wetland did not make the standards pertaining to densities of birds, invertebrates in main channel and tidal creek habitat, invertebrate richness in tidal creeks, or fish richness in main channel or tidal creek habitats. In order to effectively remediate, we need to understand the mechanisms behind these underperformances. Unlike the vegetation, where elevation and soil salinity appear to be important, the mechanisms behind the underperformance of birds, invertebrates, and fish are less obvious. And we really, at this point, don't completely understand them. We have started by looking at spatial and temporal patterns in the abundance of the various groups to determine the mechanisms behind this underperformance. Okay. And as I said, I'm going to discuss birds and macroinvertebrates in tidal creeks, the density of birds. Okay, this graph shows the density of birds on the y-axis in the 4 wetlands: San Dieguito Wetland, Carpinteria Salt Marsh, Mugu Lagoon, and Tijuana Estuary. And this shows the density in 5 bird gills: shorebirds in green, waterfowl in blue, wetland birds in kind of off blue, seabirds in another shade of green, and upland birds. And what you can see here is that San Dieguito Wetland has, and this is for 2019, San Dieguito Wetlands has a very low density of shorebirds. So there seems to be something about the restored wetland that is affecting shorebird abundance. This slide shows patterns of abundance of those bird groups over time in just in the San Dieguito Wetland. And one can see that there has been a general decline in total bird density, which was evident from Mark's talk, and of shorebirds and waterfowl in particular over the last 8 years. We have entertained several hypotheses to explain underperformance in bird density and bird feeding, and these include insufficient quantity or quality of habitat, for example, the mudflat habitat, which is critical to shorebirds, and insufficient food resources, worms, that was also indicated in Mark's talk. This slide shows the density of macroinvertebrates in tidal creeks. On the y-axis is the density of macroinvertebrates, number per 100 centimeters squared, in the 4 wetlands: San Dieguito, Carpinteria Salt Marsh, Mugu Lagoon, and Tijuana Estuary. Polychaetes are indicated in green, oligochaetes in yellow, and the other is a gray. And you can see that San Dieguito Wetland has much lower densities of worms than the reference wetlands. This is concerning because worms are an important source of food for birds, for fish, and for other invertebrates. As I showed with the birds, this is a timeline showing the density changes in invertebrate density over time. Again, polychaetes and oligochaetes are in green and yellow respectively. And you can see that the density of worms has remained pretty low between 20 and 50 and is relatively unchanged over the past 8 years. This compares to the lowest reference wetland where densities are typically around 200 per 100 square centimeters. Again, this pattern is concerning because we would really expect an increase in the abundance of the worm group that attain high densities in the reference wetlands by now. Hypotheses that we have considered to explain underperformance of invertebrates include soil properties, soil texture, and soil organic content, for example. The topography and elevation of channels. Some of the channels in San Dieguito have fairly high elevations compared to the reference wetlands, and this could be one of the mechanisms leading to the low abundance. And then we've looked at site history. In the past, we've actually compared areas in San Dieguito that have that were present prior to the restoration, and there is some evidence that San Dieguito may historically be depauperate in invertebrate. Okay, so this slide deals with future directions in these biological standards. To understand the mechanisms leading to the underperformance, we will, 1, conduct analyses of existing data to explore spatial and temporal patterns in abundance, differences in abundance among taxonomic and functional groups, and we will look at the local and regional context, and we will pay attention to physical factors. And we will also, secondly, we will collect new data in the coming year. This includes data on soil properties, data on water quality, channel topography and elevation, and we will conduct targeted experiments. This slide outlines the progress of San Dieguito Wetlands toward compliance. The cover of salt marsh vegetation is increasing and is on a promising trajectory. The density of birds and bird feeding, invertebrates, and species richness of fish are underperforming relative to the reference wetlands, and these are not on a promising trajectory. For a number of these groups, it's actually been a decline since 2016. But there is a 10-year milestone on performance of project compliance, and that requires that the performance standards must be met by 10 years after the initiation of fully implemented monitoring. This requires that 3 consecutive years of compliance in the relative standards must occur by 12 years, or remediation will be required at the discretion of the executive director. Given this deadline, there is an urgency to determine the causes for the underperformance of these biological standards, and we will be focusing on those in the coming year. That concludes my presentation, and I'll be happy to entertain any questions.
Thank you, Steve. If you would just unshare your slideshow for a second. And now we'll open it to any questions that anybody has. Again, you can feel free to type a question into the Q&A box or just raise your hand in Zoom and I will unmute you. And I did want to mention, we did get one question earlier about whether the presentations will be made available. And the answer is yes. If you go to the question and answer, you should see, I put the website of the UC Santa Barbara Songs Mitigation Monitoring website. The presentations will be posted there. Maybe not today, but very shortly. So go ahead and check out the website in the future and take a look. Okay, we have a question from Dick Roll. Do you have an acreage of the vegetated habitat in the 20 to 30% category? And I'll pass it off to either Steve or Mark if one of you wants to take that.
It's about 20 acres. So we have about 72 acres in 30% cover or more, and the design requirement is actually about 93 acres. So it's about what, 21 acres?
Yeah, Dick, I mean, we can check that and get back to you.
I think that's right. Mm-hmm.
Okay, we have another question from Karen Thorne. For the habitat category called Other, would you classify these as salt pans? And is there any ecological value observed? And she says, nice presentation.
Mark, you want to go for that?
You know, if they probably do, they do have characteristics of salt pans in some cases that when they're high up. The Carpenter Salt Marsh, for example, that there is some salt pan habitat that's pretty sparsely vegetated. So, you know, that would be categorized as other. The thing about salt pans is, though, they're not included in the final restoration plan as a habitat. Mm-hmm. And so they do, there's a staff-linted beetle, Bledius, that really likes salt pans.
Yeah.
And I suppose that some birds would be using them to, you know, be feeding on these beetles. But we're evaluating the performance of this restoration project in terms of the criteria that are provided in the SONGS permit. Mm-hmm. And salt pan is not one of the habitats that's provided. But I mean, Rich could chime in on that too.
Yeah.
Yeah, I guess what I'd say about it is that it's really more just unvegetated vegetated marsh, right? I mean, it's not really, it doesn't have the normal characteristics that even a salt pan would have. It's not distributed the way where a salt pan would be. And so not only was it not planned, it also doesn't really look like a salt pan and probably doesn't function like a salt pan. I mean, some of it does have sparse vegetation. It's really just not reaching and even our definition of the percent cover it takes to reach salt marsh, vegetated salt marsh is very low, right, by natural wetlands. And so most of this other habitat really is just very sparsely vegetated area that is where a salt marsh should be.
Yeah. And I would kind of add to that, what it really is transitional habitat, really. It's, you know,
right. So, yeah, that's right. So some of this habitat that's high and sparsely vegetated with time might develop more vegetation.
Mm-hmm. That's why we're doing that experiment.
That's why we're doing these experiments. So it's not a lot of acreage. I mean, I think we generally believe that the best bang for the buck in terms of planting is to fill in gaps lower where plant development it's easier to get plants established. Mm-hmm. So that's where we're thinking the focus should be. But, you know, there's also the idea of maybe getting, you know, plants going at the higher elevations if it's possible. So, but there's not a lot of acreage up there.
Yep.
Great, thanks everybody. All right, we now have a question from Susan Scatolini. Wouldn't you expect that as the salt marsh vegetation fills in and there is less open habitat and open water, the bird abundance would decrease and wetland birds would increase? Who wants to take a stab at that?
Well, probably. I mean, the fact is that most of the birds are shorebirds, waterfowl, but going to shorebirds and wetland birds. And typically the species richness in salt marsh habitat is much lower than it is in mudflat habitat. So when we are Marsh showed in his talk that there is a slight, there's a level of of mudflat that is slightly below the 10%, and that's because this mudflat habitat is being filled in by Spartina, and that's a good thing, but it's excluding, shorebird habitat for one. And so that was one of the potential mechanisms that we considered to perhaps explain the downward trend in total bird abundance.
I just wanted to make a comment about the question. It talks about as the salt marsh vegetation fills in. And so I think that, yes, there is some potential loss of mudflat and even potentially some loss of open water could happen, and then you would be losing waterfowl and you would be losing shorebirds. But that's not really the mechanism that's happening as the salt marsh fills in, because those species mostly are not using the habitat where the salt marsh is filling in. So,
Yep.
So there is some change in mudflat, as Steve was just talking about. There's not really been a change of subtidal, and so I don't think we can attribute the decline of birds to the habitat changes.
Mm-hmm.
I agree. It seems like there's really plenty of quote mudflat still available.
Yeah.
And so that, could be a possibility. It could be something about the quality of mudflat. I mean, if you think about the situation with the invertebrates, they've been low the whole time. And bird abundance has declined over a period of several years.
Mm-hmm.
So there's something complicated going on that we don't understand right now.
Great, thank you, everybody. And now we have a question from David Cannon. Have you performed any analyses to look for any relationships between worms and bird and fish use at the reference sites compared to San Dieguito, with a focus on why bird use and usage was high in the early years and has decreased over time?
No. We
haven't done that. Yeah.
But I think that is encompassed within Steve's talk in terms of the things that would be interesting to look at going forward.
Mm-hmm.
Yeah. And as I said, it's interesting that the worm abundance it's not like the worm abundance has declined coincident with shorebird abundance.
Right.
The worms have always been flat and the shorebirds have declined.
Yeah.
And I will say that the difference between San Dieguito and Carpinteria in terms of making the standard or not making it are very small.
Mm-hmm.
I mean, they almost made it. So,
yeah.
Okay, thanks everybody. We have a question from Justin McCullough. Noticing lower abundances of fish, invertebrates, and birds, lower species richness, higher vegetation cover, etc., at the Tijuana River estuary, have any physical, chemical, or other comparisons between the Tijuana River estuary and the other two reference sites been conducted that might get at the heart of the issue? Any thoughts on lower numbers at TJ?
Well, we have done some analyses of, in particular, the invertebrate communities. And if you look at everything thrown in together, like in a multivariate approach, Tijuana and Tijuana Estuary and San Dieguito tend to cluster together. And we have not done any comparisons at this point between Tijuana and San Dieguito, although that we have done some comparisons between Carpinteria and San Dieguito, and we're going to continue that in the future. That's a good suggestion.
yeah.
Justin says good luck.
Yeah, good luck with that.
And I just make a comment. Yeah, so clearly we're interested in these sorts of comparisons. And in the past, we did do some experiments where we moved sediment to look at how invertebrates did in sediment from the different marshes and some sort of controlled experiment. And that's probably the sort of thing that we may need to do more of, because it's very hard to tease all these things apart, because we've got wetlands that are in different locations, and you don't really know how much of the difference is due to location or history, or even currently different environmental conditions versus the mitigation site versus the restored sites. And so we'll probably need to do some experiments, and then pay as much attention as we can to sorting out the analyses.
Yep.
Great. Thank you, everybody. I don't see any more questions at this time. I'll give everybody one last minute in case you want to frantically type in another question or raise your hand in the Zoom, and I would be happy to unmute you and let you ask your question in person. Okay, I'll give it just couple more seconds. Okay, I think that's it. So I just want to thank everybody for participating in our webinar today, and for kind of helping us get through this new format that we have. Special thanks to Steve and to Mark for your presentations today. If you look into the Q&A, there is the website address for the UC Santa Barbara Songs Mitigation website. Again, the presentations will be posted there later. There's also just a treasure trove of good information about the Songs Mitigation project there. I just want to say thanks again to everybody for participating, and I hope you have a great rest of your afternoon. Bye, everybody.